coefficient. Actually, Pearson correlation coefficient has some limitations. What are those limitations? That sometimes if there are some extreme values inside the data, the Pearson correlation coefficient will be changed or will be distorted with those extreme values. So in those cases, and especially if we have the ranked data or the data is ordinal, we have to use Spearman rank correlation coefficient. So we don't use for the ranked data, we don't use the Pearson correlation coefficient. Okay, so how to apply Spearman rank correlation coefficient? This is the formula. Okay, in this formula we have summation d square, and this summation d square is actually the difference between the ranking. So let us start this Spearman rank correlation coefficient with the help of one example. Very simple example we consider. We have bivariate data. Okay, suppose you have two datas, data x and data y. Suppose this is data x and this is data y. And first of all, we have to rank this data. So how to rank this one? Suppose ranking is actually relevant. It depends upon situation to situation. Some data they are ranked ascending in the ascending order. Some data is ranked with the descending order. So it depends data to data. But how can we rank it? Suppose this data is the quiz points in the test of quantitative course. Okay, suppose X is the quantitative quiz 1 score. Okay, so this student who got 7 out of 10, okay, I will rank it as best. Okay, so this is the first ranked. Okay, so second one is who got 6 out of 10, he will be ranked 2, and the third student who got 4 out of 10, he will be ranked 3. Okay, so this is called the ranking. These are the actual data and this is the ranking. Okay, now suppose this is another course, suppose for some finance course, and we consider it as y. Okay, we want to test that those students who got good grades in the quantitative, they got the good grades in the finance or not. Okay, we want to check this relationship. So we can see here the same student who got 4 in the quantitative, he got 9 in the finance. So 9 is best, so I will give him the rank 1. Okay, then we have 3, so this is rank 2, and then the student who got 3, he will be given rank 3. So these are the ranking now. So D is actually the difference between the ranks. So 2 minus 3 is minus 1, 3 minus 1 is 2, and 1 minus 2 is minus 1. And now we take the square, 1, 4, 1, and the total is 6. So summation d square, which we need in the formula, is 6. Okay, now we go back here in the formula. I will put the values here. 1 minus 6 multiplied by summation d square, which is also 6. So this 6 is according from the formula. By default, it will be here. Whatever the data is provided, this 6 will not be changed. Summation d square, it will change with respect to the data. N is 3, and 3 square minus 1. So now you can just calculate it. It will be 36 over 3, and this will be 9 minus 1, 8, so 24. So now you can calculate it. It will be minus 0.5. Sorry, it will be 6, 6, and 6, 4.
6 square, doctor.
Yes, 6 square, 9. Sorry, what? Yes, it will be 6 by 4. Okay, 6 by 4 means 3 by 2. 3 by 2 is 1.5. Okay, so yes, minus 0.5. Okay, so here you can see that it is negative. Okay, so two things that you get here. Negative, there is a negative relationship between the quiz in the quantitative and the finance. Okay, and the relationship is weak because it falls. If you see here the table, okay, 0.5 falls in this range. Okay, 0.45 false here, so it is weak negative. So you can say here that there is a weak negative relationship. Weak negative relationship. So this means that the student who got good in who performed well in the quantitative course, they didn't perform well in the finance course. Okay, so means there is no there is a weak relationship and the opposite negative relationship between x and y. Okay, now we take a clear example. So here we have the total annual cost of player, wages for the 8 football clubs, and their final league position given below. So these are the wages of the players, and these are the team final league position. For example, this team is getting the wage 45 million dollar. Okay, they got the first position, and this team who got 32 million, they got final second league position. Okay, so first of all, tell me which one is x variable and which one is y. What do you what do you think? Which one is x and which one is y? Yes, anybody?
The wage is X.
Wages are x and the final league position will be y, because we can expect that a team who is getting high salary or high wages, they will perform well in the final league position. Okay, so we can consider wages to be x and the final league position we will consider as y. Okay, now you can see positions are already ranked. Okay, so there is no need to re-rank it. Okay, because these are positions. Position mean ranking, so no need to re-rank it. I will just rank the wages. So the wages I will rank. Okay, so let me rank them here. Let me rank the x variable to be here. So suppose uh, the high wage is ranked best. Okay, suppose the high wage is ranked best. Okay, I will put here 1. Okay, then second highest is 41, so I will rank it 2. Third highest is 32, so I will rank it 3. Then this one 4, and then this one 5, 6, 7, and this one 8. Okay, so this is the way how do you rank the variables. Okay, now here I will calculate d. Okay, 1 minus 1 0, 3 minus 2 1, 2 minus 3 minus 1, 8 minus 4 4, minus 1 1, minus 1 minus 3. Okay, so that's all. Now I will just calculate d square. 0 1 1 16 1 1 1 9. Okay, so get the total. 1 2 18 19 20 21 30. So summation d square is 30. So let us calculate the Spearman rank correlation coefficient. 1 minus 6 multiplied by 30 over 8 multiplied by 8 square minus 1. Okay, so now you need to just calculate the answer, and the answer is 0.643. Okay, so two things we get. First thing is there is a positive relationship between x and y, means more wage, more good position you will get. Okay, means high salaries are associated with the high positions, mean good positions. Second thing is this relationship is moderate. Okay, because this falls here in this one 0.6. Okay, in this category. Okay, in this one, so fair, moderate, positive. This mean moderate means that not all teams who got the high salaries, they got the good positions. Suppose you can see here, this is the eighth, the lowest salary. Okay, this team got the lowest salary, but they perform well, means they got fourth position. And similarly here you can see they are getting, this team is getting the fifth highest salary, but they are getting the last position. So this means that not always high teams high wages team, they are getting the high position. Overall, they are, yes, they are getting good position, but not always. So the relationship is moderate. Okay, so in this way you can interpret the results. Two things you have to interpret: first is direction, yes, positive, high salaries, good positions. And second thing is the strength. The strength is moderate, it is not strong. Strong means that always high team salaries, they are getting the high positions. Okay, now sometimes it happens that we are given a question, suppose this one. Okay, and we look, suppose you have this question, and here suppose this is not 27. Okay, suppose this is 32 again, means 32 is repeating twice. Okay, 32 is repeating twice. So how to rank now? This is 1, this is 2. Okay, and now you have 33, 32. Okay, so this means this is 3 and this is 4. So this is biased ranking, because similar values you are giving the rank 3 and 4, which is not correct thing. So what you need to do in this case, if you have two similar values, so what you would do in that case, so you will put here 3 plus 4 divided by 2. Take the mean of 3 and 4. Okay, so you will get here 3.5. So assign the rank the mean of 3 and 4. So 3.5, and this one should be 3.5. So 3.5, 3.5 to the same values. So you need to take the, you need to give the mean rank of two similar values. Similarly, if you have three similar values, okay, means the next value is also, this one is also 32. Okay, suppose this value is also 32. So what you would do in that case, so 3 plus 4 plus 5 divided by 3, okay, means you get 4. So you will give rank 4, 4 and 4, and the next value then you will give it to 5, sorry, 6.
يا رجال.
Sorry, 6, 7 and 8. So in this way you can rank the rest of the values. Yes, Samjit.
Why, doctor, we just put three of them in the rank 3, for example?
I'm saying, for example, if it happens that you have three similar values in the data, how would you rank them?
Okay.
Okay, I'm just giving you an example that if we have three similar values in the data, we cannot rank differently. Okay, means the first 32 you will give the rank 3, and second 32 you will give the rank 4, and the third 32 you will give the rank 5. This is the biased ranking, so you should not do in this manner. So what we do, we give the mean rank to each that number. Okay, so let us take a clear example here. Suppose here we have the critic ranks of the six films, the six best films. The critic ranks to these films. For example, this is the best film by the panel. Okay, the panel is giving the ranking. So this is the best film in front of the panel. This is the ranked second. This is ranked third, fourth, fifth, and sixth. So these are the six films we have, and accordingly the second data that we have is the profit they are making. For example, the box office taking. Okay, so this is 2.2 million. The first ranked film is getting the profit 2.2. Second ranked film is getting the profit zero point 0.8 million. The third ranked film is getting the highest box office taking 7.3 million. Okay, fourth one is 1.6, and fifth one is again 0.8. So 0.8 and zero point 0.8, two times it is repeating here. And then we have 0.5. Okay, so first of all, the suppose this is X and this one is Y. Okay, now look, uh, the first data is already ranked, so I will not touch it. This is already positioned, so I will not touch it. It is already ranked data. Second one, we need to rank. Okay, so the best profit I will consider as the best rank. Okay, the best profit is 7.3. So we give this value to the rank 1. Okay, this is the first ranked value. Okay, next one is 2.2. So I will consider it second. And 1.6, it will be considered as the third one. Okay, now zero point 0.8 and 0.8, they come at 4 and 5. Okay, so what I will do now, 4 plus 5 over 2. So the ranking for both of them will be 4.5 and 4.5. Okay, the next one I will not give the rank 5 because 5 I have consumed in the in calculating the rank of fourth and fifth one. Okay, so next one will be 6. So this is the way how do we rank if we have two similar values. Now you can get the difference between the ranking. So first one is you just calculate in this way. First one is 1 minus 2 minus 1, 2 minus 4.5 minus 2.5, 3 minus 1, 2, 4 minus 3, 1, 5 minus this one minus 0.5, and 6 minus 6, 0. Okay, the next one is you have to take the squares. Okay, square d square. Okay, 1, 6.25, 4, 1, and here you have 0.25, and here you have 0. Okay, now let us calculate the summation d square. Summation d square will be sum of all 1, 7, 11, 12, and 12.5. Okay, 12.5. And now you can apply the formula. 1 minus 6 times 12.5 summation d square, and there are 6 n square minus 1. So I just applied the formula, and now we need to get the solution. The solution is 0.643. Okay, so answer is 0.643. So from here we can say that the relationship is positive and the strength is moderate. Okay, the strength is moderate, so you can say that not all those films who got the good ranking, they have the same box office taking. Okay, so we can say that this relationship is positive. Almost all of the movies, they got a good ranking, they have the good box office taking, but not all. Okay, so this relationship is positive and but moderate. Okay, so that's all with the Spearman rank correlation coefficient. Look in the Excel sheet if you want to do this kind of analysis. Okay, so what you need to do, uh, you will copy the data. For example, this data I will take it to Excel sheet. Okay, let me copy this one. It's better if it is in the column wise format. So just go to the Excel sheet. Okay, so let me take it to the Excel sheet here. uh, okay, so suppose this is X and this one is Y. You have this data, suppose. Okay, now what you need to do is, first of all, you have to rank. Okay, you have to rank it. So how Excel rank? Okay, actually, like you had in the Pearson correlation coefficient. If you want to calculate, you can simply write here. Suppose let me write this data in the column wise format. Okay, so let me write here X and Y, and here I have 1, 2, 3, 4, 5, and 6, and the second data is 2.2, 0.8, and 7.3, and 1.6, and 0.8 and 0.5. Okay, so let me delete these rows. Okay, okay, now we have here x and y variables. Okay, so these are the rank data already. Okay, so this needs to be ranked. Okay, this needs to be ranked. So let me rank the y variable. Rank y. So how do we rank in Excel? You know, the formula that we use here is equal, okay, rank. Okay, rank dot eq, this one. Okay, rank dot eq. Okay, first of all, number. Okay, I want to rank this number. Okay, comma. Then reference range. You have to give the reference range. Reference range is this one. This whole data, I have to calculate the rank of B2. Okay, so this one. So what you need to do, okay, just what you need to do is lock it. Okay, so just lock these two. Uh, okay, I just press F4 to lock these two because I want to lock this column, otherwise it will be changing whenever I copy it down. Okay, now comma, then it will be asking that you want to rank it ascendingly or descendingly. Okay, suppose if you put here 0, it will rank it in the descending order. Okay, for example, this one is considered as 2. Okay, and then and so on. Okay, so you can see here this one, it considered it as 1. Okay, and this one is 2, this one is 3, and this one is 4. Okay, actually,
Doctor,
yes,
when designing is uh, from lower to upper, right?
yes.
Okay.
Let me tell you. Okay, look, uh, um, whenever we the best thing, okay, the best thing is always considered as the best rank. Okay, for example, you can consider this one as the profit, the best profit. Okay, so it will be ranked as 1. So you can consider this data as the descending. Descending means that the best or the highest value will be given the means the best rank, the 1. Okay, highest value you are giving it means 1. Second highest you will give 2. Okay, this is called as descending. Ascending means highest value will be given the lowest rank, mean the high position. Not we should not say in this way, because high position is 1. Okay, so the last position we will give to the highest number, that is ascending order. Okay, so in this way you can go. Okay, now here Excel will not give you the that type of ranking, so your answer will be slightly different because Excel is giving 4 and 4, the same similar values. Excel will be giving the same rank. Okay, 4 and 4, it is not giving it 5, it is not giving it 4.5 as we did. Okay, so that thing, it will not means it will not be changed your answer too much. Okay, slightly changed, but no problem that one. Okay, so once you have the rank for y, the next thing is you have to calculate d. Okay, so d, how would you calculate? Equal, okay, this minus y rank. Okay, just enter, and now just copy it down, and now here you have to calculate d square. Okay, d square you have to calculate. So how to calculate? I will just take this term and power 2. Okay, 1, and now copy it down. So here we get the d square. Now here I need to get the total. Okay, the sum equal sum from here to here. Okay, so this is total. We get 12 point 12 point something in when we did it here. So we got here
12.5.
Yes, 12.5. So here we get 11. So no problem. It will not be change your answer too much, but slightly change. Okay, so now you can apply your formula, RS. Okay, RS is equal to just 1 minus 6, and this one, multiply by this summation d square. Sorry, equal sign, so that okay, e square, and divided by n. Okay, what is n? N is 6. So you put here 6 multiply by 6 square minus 1. Hopefully it will give me the answer. Okay, no, we did some mistake. So what mistake we did here? I think we just break it here.
I think, Doctor, after 2, you went -1.
Yes, now it is fine. No, we just need to put the bracket after divide. Okay, because here we have the complete divided by the, means this whole term divided by the this whole expression. So this require a bracket. Okay, so if you don't use the proper bracket, so you will not get the answer. So here we get the answer 0.685. So slightly changed as we got the answer 0.643. Slight change, but almost it will not change the result overall. Okay, anyhow, this is the Spearsman rank correlation coefficient. So whenever you do it, okay, because if you want to be more precise, okay, if you want to be more precise, you have to rank in this way, 4.5 and 4.5, like we did here. It will give you more accuracy as compared to the what the Excel did. Okay, so anyhow, now we come to the second method, that the last method of this chapter, regression method, the simple linear regression. Linear regression means, okay, look, the Pearson correlation coefficient is just a number. Okay, it will provide you the answer in the form of number 0.9. Okay, but from the number you can identify two things, the direction and the strength. But with the help of simple linear regression, you can find a mathematical form, okay, mathematical form of the relationship y equals to a plus bx. So it calculates the association between x and y variables in a mathematical way. Okay, so what is the benefit? The benefit is you can predict, you can forecast, and this equation is called the line of best fit. Okay, the line of best fitted line in the data. Suppose you have a statistical scattered diagram. Okay, if you have scattered diagram, you have the points like this one. Okay, the statistical data is in this way. You pass a line. Okay, this is called eye fitted line. You just look at the trend of the points and you pass the line. So this is a random line you pass. Okay, this is called eye fitted line. The best line which passes in a best manner, okay, is the regression line. The regression line, okay, what it does, it minimizes the error. Okay, the error means the distance between the point and the line. So that's why it is called the best fitted line. So which way is the best, fitting by eyes or fitting by the regression line? So always keep in remember, the random line you pass is not the best fitted line. Okay, the best line will be the line that you get with the help of the regression line, because regression line minimizes the error. Error is actually the, okay, look at this point and this line. The distance between this point and the line is called the error. Okay, how many points do you have here? There are many points. Okay, there are some points, they fall on the line. Okay, these have zero error. Okay, but the point, if the point is far away from the line, okay, they have the bigger error. Okay, so suppose this point and this one, okay, this is called the error. Okay, the best fitted line, if you pass any other line, okay, suppose you said that this is also the line, okay, and you said that this is best fit line. No, this is not the best fit line, because the regression line minimizes the error. It passes in such a manner, such a best manner, that the sum of the all errors, okay, will be the minimum. If you pass any other line, the error from this point to that line, okay, so this error and this error, if you sum all of them, it will be bigger than the errors of best fitted line. So regression line is the best line. That's why its name is the best fitted line. Okay, you will see it is the best fit. It is called the line of best fit. Okay, because it minimizes the error. Okay, now the equation of the line of best fit is y equals to a plus bx. So a here represents the intercept, okay, and b here represents the slope. Okay, now what are the formula? How to calculate the line of best fit? Okay, how to calculate a and b? The formula for a and b are a bit complicated. Okay, so they will be provided to you in the exam, but you must know how to implement these formulas. B requires, okay, first of all, you have to calculate B because B is used in A. Okay, so first of all, you have to calculate this B. And B requires this product XY, and it requires summation X square. Just two things. Rest X, summation X, summation Y, and all will be given to you in the question. Okay, so you have to prepare this product XY and X square. So rest of the things are simple to be calculated. So let us go to the question and let us solve. So here we have the same question, the sales volume of ice cream and the temperature. And you know, this is X and this is Y. This is important thing that before starting you have to fix X and fix Y, which is the independent variable and which is the dependent. This is the first important thing that you have to consider before starting the questions. Okay, now you have X and Y. Okay, so what we need according to the formula, we need X, Y, this product, and summation X square. So let me calculate these two columns. So first of all, I calculated X square, and then I calculated XY, and we get the sum of all. Okay, so get the sum of all, and just now you need to go to the formula. So just two columns you need to prepare. X square, for example, 14, take its square, you get here 196. 18, take its square, so 324. And this product, okay, X and Y, you need to multiply 3 into 14, you get 42. So in this way you get the product. So get the sum of all, put the values inside the formula. First of all, you need to calculate B. So B comes out to be 1.314, and then you get the A. Okay, so A comes out to be minus 16.286. And so you have A and B. So the best fitted line equation is given by this one. So this is A, this is B, and this is X. So Y equals to A plus BX. So now, you know, Y is sales and X is temperature. Okay, so just put the temperature here and you will get the sales. For example, this is beauty of mathematics. Look what we did in this whole example. We converted a statistical data into mathematical equation. Okay, we converted statistic into mathematics. So this is what the regression equation does. Converting statistic, okay, you had statistical data and you converted into mathematical form. Okay, what is the benefit of writing mathematical form? Okay, now statistic, the disadvantage of statistic is that suppose you had the data in discrete form. Okay, you recorded the data when the temperature was 14, you got 3, sales were 3, but you don't have the data for when the temperature, if somebody asks you if the temperature is 16, what will be the sale? No answer. You don't have any answer that what will be the sale if the temperature becomes 16 degrees centigrade. What will be the sales if the temperature is 26 degrees centigrade? No answer. What will be the sale if the temperature is 23? No answer. But whenever you have the regression equation, you put here the temperature. Okay, if the temperature is 16, I put here 16, I will multiply it with this one, and I will get the answer. Okay, so the benefit of this is called prediction, predicted value, or the forecasting, that you just know the value of x and you get the value of y. Okay, this is called predicted values, prediction. Okay, and regression help us in predicting. Yes, Samjad.
Doctor, I didn't get how you recognize that this data for X and this data for Y.
Look, this requires the general knowledge, the general knowledge. Look, what we have, we discussed that thing in the previous lecture, if you remember. Temperature, why temperature is x? Okay, can you change the temperature? Can this variable sales change the temperature?
No.
No. So temperature is independent, and sale, yes, sales can be changed by the temperature, so sales will be y. So in the
Okay.
context, you have to understand that temperature here will act as x, and sales will be considered as y. So you have to look at the context of the question. Then you have to identify that this variable will be considered as x and this one will be considered as y. If you means consider this temperature as y and this one x, whole analysis will be wrong. Whole analysis will be wrong, because you are considering that temperature will be changed, and your whole analysis here in the at the end, you will put here temperature, and here you will put sales. So this means that you will calculate the temperature if you know the sale. No, this is not so. This is illogical that if you know the sale, then the temperature will be that one. No, it is not vice versa. Okay, so you have to appropriately choose the right variable, dependent and independent.
Mm-hmm.
Then you have to start your analysis. Okay, then at the end, whenever you reach to your final equation, you can just put the independent variable, you will get the dependent answer.
Okay. Understand.
Okay, so okay, now there are few advantages. Okay, the first advantage is that we get the expected value of x. Sorry, expected value of y, means we can predict. It help us in the prediction. Second thing is, it tells us about the rate of change, the slope, means how, if the temperature will be increased by 1 unit. Look at this thing. uh, Look at this thing. This is slope. It tells us that if the temperature is increased by 1 unit, okay, if it is increased by 1 degree centigrade, okay, 1 degree centigrade, it goes up. What will be the impact on sale? Okay, so sale will be increased by 1.3143 liters. So this is the slope. Okay, the regression line will tell you the rate of increase. Okay, what will be the rate of increase in the in the sale if the temperature is increased by 1 unit? Okay, what will be the impact on our sales? Our sales will be increased by 1.3143 liters. Okay, so this is the benefit of regression line. And second benefit is we can get the prediction. If we know the temperature, we can get the predicted or forecasted sale. So these two benefits are these are very important benefits of regression equation. But regression equation has few limitations as well. Okay, what are the limitations? Look, in if I say calculate the sales. Okay, my question is, calculate the sales when the temperature is 0 degree centigrade. Come back here. My question is, calculate the sales when the temperature is 0.
It will be minus 16.
Yes, minus 16.286
Yes.
liters. Can sale be negative?
No.
Can sale? No. So this answer is means unreliable. Okay,
Yes.
means illogical answer. Okay, so why it happens? Look at the question statement. Okay, look here. If you go to the question, the minimum temperature was 14. Okay, the maximum temperature was 25. If we go too much away, means 0 degree centigrade will be here. Okay, too much away from the minimum value of the data, the answer will be unreliable. Similarly, if I say calculate the sales when the temperature is 45 degrees centigrade, okay, this 45 is too much away from the highest temperature. So the answer, you will get an answer, a mathematical answer you will get, but that answer will be unreliable. Okay, what are the reliable answer? Whenever you calculate, for example, for 16, whenever you calculate for suppose 2023, for 24, okay, you can calculate for 26. It is outside the data, but you can calculate for 26, you can calculate for 13. But if you go as far away from the minimum value, or as far away from the maximum value, more you go away from the maximum value, more unreliable results you will get. Like if you go to 0 or 1 or 2 or 3, you will see you are getting negative answers. So these are unreliable answers, because we move too much away from the minimum value. So the reliable answer will be inside the data. Okay, inside the data means bigger than 14 and lesser than 25 degrees centigrade. Or if we go outside, we should keep ourselves very close, means 26, 27, 13 and 12, it's fine. But more you go away, more unreliable results. So these are the limitations. Okay, these are the limitations of regression analysis. So you must know that what are the limitations of regression analysis. This regression analysis could be done on Excel. It's very simple. Okay, very simple. You can just okay, open this is the temperature and the sales. Okay, this data, this is X, temperature is X and sales are Y. So how to calculate the regression line? Okay, it's very simple and very interesting. Look here, what is the regression line equation? Y equals to A plus BX. Okay, this is the regression line. So how to calculate A? Okay, how to calculate A? A is equal to, what is the formula? A is intercept. Okay, equal intercept. Okay, intercept this one. Knowns Y. Okay, knowns Y are from 3, this one, this column. Okay, comma, knowns X, this one, close the bracket. Okay, now you get the same intercepts, minus 16 point, as you got by hands. Okay, now second thing is B. Okay, B is the slope. So equal slope, okay, this one, known Y's, comma, second thing is known X. Okay, close the bracket, you will get the same answer, 1.314. So here your regression line will become Y equals to A minus 16.2827 and plus 1.3143x. Okay, so this is your regression line. Here you can calculate the predicted values. Okay, for example, these are the actual. Okay, these are the actual values you have, and here you can calculate Y hat, the predicted value. Okay, Y hat. How? Equal. Okay, equal. Equal, and this one. Okay, the intercept. Okay, intercept. Just lock it. Okay, just lock this intercept. Sorry. This one E2. Okay, lock it, F4. Yes. Now plus the slope. Okay, I want to lock this one as well, F4, lock it. and multiply by x. What is x? X is temperature. Okay, so just press. So this is the predicted value. Okay, keep it, remember that actual value and the predicted value, they should be close. Okay, because we are actually using the regression line to get this predicted value. Okay, now let me drag it down to get all predicted values. Okay, so actual value is 7 and predicted value by the regression line is 7.37. Actual value is 8, predicted value is 10. So this value is far away from the regression line, so it has more error. Okay, 10 and 12.62, 14 and 11.6, 18 and 16. So these are the predicted values. Okay, now look here. Suppose I said you calculate the predicted or the forecast when the forecast for the sale when the temperature is 17 degrees centigrade. Okay, you would say that the sales will be 6.05 liters. Okay, now I would say you when the temperature is 23. Okay, when the temperature is 23, the sales will be 13.94. Okay, when the temperature is 15 degrees centigrade. Okay, 3.42. If the temperature is 26, 17.88. If the temperature is 35 degrees centigrade, so 29.7. So, but these are unreliable because we are going outside. But still, we are getting some answer from the regression line. Yes, Amjad.
Doctor, it can be reliable, doctor, when we have other number for y, because in the formula when we're trying to solve it and find the equation y equal a plus b x, okay?
Yes.
We are using for finding a and b, we are using the values of x and y. Here, the new values you add doesn't have values of y. So
Look, it doesn't require the values of y, because when we use this equation, okay, what is this equation? We just need x only. Okay, but look, y is used when you calculated a and b. When you calculated a and b, you use those y's. Okay, so this equation still it has y, but it is in the form of these constants. Okay, so still we calculated these y hat. Okay, they don't require y, but when we calculated a and b require y values according to the formula. If you know the formula for a and b, they are strongly depending upon y and x, both of them. So
yeah.
x summation y. Okay, so it doesn't mean that because here when we are predicting, we are not using y values, so it doesn't mean that we are not using y. Y has been used. Okay, y has been used in calculating a and b. So whenever you are predicting, prediction doesn't require y. It just requires x only. You just put here x, okay, and you get the value of y. So these are the predicted values of y. Okay, because why we are calculating, so that's why we are not using these values of y here. These values have been used.
Okay, and doctor, about b, doctor, can be negative?
Yes, negative if there is inverse relationship.
Okay.
Okay,
So
if the relationship between x and y is inverse, like the demand. Okay, suppose this one, you know, the data that we had here. Yes, this one in this example, the price and the demand. Okay, you have this this negative. Means the inverse relationship, negative relationship. Okay, so let us calculate for this data. Okay, you will see that b is negative. So b equals to equal slope. Okay, known y's are sale. Okay, comma known x. So you will see here it will be the negative. Okay, you can see here it is negative. So b is the slope, and if the question is means in which two variables are negatively associated, then the slope will be negative. Okay, so everything could be possible.
Doctor, you said, Doctor, before that if we increase y, no, sorry, if we increase the value of x, or if the value of x increase by 1, the y will also increase.
Yes, yes,
by,
in that case. Yes,
by the
yes,
slope.
yes. Here
But
you will say decrease.
yeah, here it will decrease.
Yes. Okay, if your slope is negative, so this means that if you increase the price, by 1 unit, there will be a decrease in sale by 0.52 units. Okay.
Okay.
Yes. Okay, so that's all with this lecture as well, and now we will move to the exercises. Okay, so let us see that what do we have in the exercises. Now you will tell me, okay, you will tell me some answers for the exercise.